Thank you, Duncan, and good morning, everyone. I appreciate the introduction, although I'm afraid you may have raised expectations beyond my ability to meet them, but thank you for that. And thank you, as always, to TCT and TCT staff for inviting me to share the stage this morning. As Duncan said, my name is David Burns, and I was the founder of Global Business Advisory Services in the United States. But in fact, I'm now in the 65th year of my life, and I've spent more than 40 of those years either creating or supplying manufacturing technology to industrial users. The last 15 years, I've spent interfacing directly with 3D printing, including leading a 3D printing company from startup all the way through to an IPO and a secondary offering. It's now a publicly held company. And over the last 4 years, I've been working directly with manufacturing clients around the world on a variety of issues. 10 of my clients over the last 4 years have been startups, and 7 of those 10 went out to seek funding during the time that I was advising them. So I have a perspective that I want to bring to you about these questions relative to startups. And when I began discussing with TCT what we might discuss this morning, they thought, well, talking about startups is important. And so I'd like to do that today. Before I do that, I want to reprise 2 ideas that I introduced actually here on the TCT stage over a couple different years. The first is that it actually took me a long time to understand this, that manufacturing is in fact a fully integrated process that begins with the moment of conceptualization, and it extends all the way to the point of final utilization of whatever it is we make. Now, to most of you, that may feel very, very obvious. It wasn't really obvious to me when I started working in manufacturing technology. I started as an industrial engineer, and one of my first jobs was working with a drilling department. And in that department, what they did was they drilled parts all day long. And quite honestly, the people who drilled those parts were the best in the world at it, and they had no sense for how what they did fit into the context of anything else. I mean, their process was completely siloed and completely independent. And I discovered over time that all the elements that start with conceptualization and go all the way down to utilization and feedback of utilization were incredibly siloed back in the 70s when I started. Now, those silos were really beautifully synchronized in a way that they worked together, but they were silos nonetheless. So, I'm from a perspective of industrial manufacturing technology. My interest in 3D printing is in industrial 3D printing. That's my orientation. To the extent to which I can talk about other things, it's only because I stumble across them as I go. But in fact, I'm from the industrial side, and that's what I'm going to talk to you about today. So, to begin with, manufacturing in my eyes is 3 steps: conceptualization, materialization, and utilization. And the other point I want to bring from my perceptual framework, and I discovered this relatively early on in my career, is that the evolution of manufacturing around the world is in fact a very long, continuous journey. I see very little that's happening today in industrial production that doesn't seem to fit my concept of this long journey. We were really fortunate in the 70s because Dr. Ono at Toyota was able to articulate this journey in many ways. He began talking about reaching the optimal state of manufacturing, where you were able to make exactly what you wanted, when you wanted, with minimum resources required. And he defined that as the optimal state, and I think he said clearly, you may never reach that. But in fact, manufacturing is a journey to try to get to that optimal state. So as revolutionary and as different as we talk about what's happening today, I see it in the context of this journey. The first company I worked with, Gleason Corporation, was 120 years old when I started. And when Gleason started, it was in Rochester, New York, they depended on hydropower. So by the river, they had a churning mill, and they had a main shaft that went down in the middle of the factory, and the machines ran off leather belts that turned on that main shaft that was turning because the water went by. And when they began to buy machines that had independent motors on them, they thought, my God, look at the innovation we've created here. But that was part of the journey. So when I analyze the journey, and I'm mostly concerned about what's happened post-World War II on this journey, I think there are, in fact, 3 distinctive stages to the journey that I've observed. The first is the analog stage. And the black line you see on the graphic is, in fact, the path toward the journey. And every time we move up that curve, we are reaching closer to this optimal state. From a macroeconomic perspective and a societal perspective, the path on that black line is critical because every inch we move up that path is productivity. And productivity means standard of living. It means people around the world live better. Productivity drives our standard of living. So this optimization journey is critical. The first stage was analog, and I was at the end of the analog stage. When I was working at Gleason's, I was there when the first horizontal machining center arrived with a tape reader on it that actually made an axis move without an operator spinning something. And quite honestly, that machine was horrifically inefficient. We could easily accomplish what that machine was trying to accomplish in an analog way without it. So what I saw that is actually the beginning of what I would call the static digital stage. We began introducing tools that were unidimensional. They were in silos, but they were in fact digitally driven. 2D CAD, PLCs, the first machine controls, all part of the static digital stage. And I'm fortunate enough now to have observed and be part of the beginning of the dynamic digital stage. And we're going to talk about what characterizes the dynamic digital stage in the context of startups because I think, in a sense, all these ideas fit together. So I think of manufacturing as conceptualization, materialization, all the way to utilization. And I see us on a continuous journey that's extended for a very long time, trying to get us toward this optimal state. Well, you may ask, what does all of this have to do with startups? And I'm getting to it, I guess. What makes this dynamic digital stage so very, very different? Well, let's look at the dynamic digital process elements. Same elements that we understand that we're in the static digital stage. We have machines, we have software, we have materials. What's different is the fact, for the first time, we're able to fully integrate from conceptualization to utilization, including the use of sensors and feedback, across the manufacturing process. We're able to integrate it for the first time. We've never been able to do this before. We're busting through the side of these silos. So the dynamic digital stage changes everything about manufacturing. So as I reflected on this talk, what I began to realize is if I think about the analog stage and I think about the static digital stage, I realize that for all of the innovations that were created at those stages, nearly all of them came from suppliers that were traditional suppliers delivering to industrial customers. Those same suppliers had been supplying products to those customers for decades. There was a well-established rhythm to the supply chain. They knew each other, they understood each other. Suppliers understood what customers needed, customers understood what suppliers were capable of, and it was quite a rhythmic relationship. What's different? This last stage, the dynamic digital stage, we suddenly have an avalanche of suppliers that are brand new to industrial production. And thus we get to the question of startups, because many of these, the components of this avalanche are in fact startup companies. So, I've had the chance to interface with lots of entrepreneurs, people who wanted to start companies. And very often early in our discussions, I'll say, so, what is it you need to be effective as a startup in this product you're going to make? And I'm waiting for the answer, I need an amazing CRM system, or I need a PhD in materials, or I need the best possible facility I could get. The answer I generally get is, I need a way to get to my customers, so a Lear jet would be really good. Or, I just want a workplace where people have fun. Or, I need a company car. So there's a little bit of gulf at the beginning of our discussions between my perceptions and theirs. And as I promised Duncan before this talk, I would actually sit down and I would go through the research, which I did, and try to discover what the research says about startups in general, and ultimately how manufacturing technology startups are different. So I looked at lots and lots and lots of different sources. I read lots of different studies. Research findings. There is no determinant number of startups that fail. There's no individual metric that people say, that's the number. We have a numerator and a denominator. Different studies cite different numbers for lots of different reasons. What we know is that at least 7 out of 10 startups fail, and the number is likelier 9 out of 10. And as I go through my talk today, I'll try to point out what I view as my opinion or my closely held feeling on what seems to be research-based or factual-based. And I can tell you, reading lots of studies, these are numbers that resonate. So we go a level deeper and we say, not only do we want to know at what rate do startups fail, but in fact, why do they fail? And depending on the study and quite honestly, the motivation of the author, you can have a whole bunch of different reasons cited, but I think there were 3 that really resonated with me, and actually they drive directly back to this question about manufacturing technology. The first, and most important that's often cited, is a lack of product and market alignment. I think it would be easy for us to say, well, what that means is that somebody invented a widget or an app that nobody wants. And of course, that happens. That's not an unknown phenomenon. But I'd like to take this thought a level deeper relative to manufacturing technology. When we talk about product and market alignment, I would like to think that many of the startups that we see, many of the technologies that are within reach right here at this show, in fact, have utility in the industrial environment if that's what they're intended for. But I have grave concerns that through the development of those products, there is not a comprehension, not of the fact that there is a need, but in fact the environment within which that product's going to be used. For 40 years, I've been in and out of manufacturing plants. I know lots of plants managers at lots of places. Generally, plant managers have 4 charts up on their wall. They've got a productivity chart, they got a quality chart, they got an on-time delivery chart, and they've got a safety chart. I don't know of one plant manager anywhere that has a chart that says how much advanced manufacturing technology stuff did I use today. Because their motivation is not about using advanced manufacturing technologies. Their motivations are about on-time delivery and quality and cost and safety. And I have encountered a number of people who have really useful technologies who don't yet comprehend that the environment that they say they want to use it in operates 24 hours a day, 7 days a week, with the expectation of 0 quality deviations, of perfect on-time delivery, and of low cost. This gap in understanding between the environment within which manufacturing technology is used and the actual creation of the technology is fairly vast. So while this is in fact cited often as the single largest cause of failure for startups, I can understand it in the manufacturing technology environment because I can observe exactly what I just described to you. The second reason often cited is that we hired the wrong team. And I was reading one article, it was actually funny, where they interviewed a guy who had started a company, and they said, well, who did you hire? And he said, well, the first guy I hired was my roommate from college, because he really needed a job, and I made him the chief marketing officer. And then my aunt made me hire my cousin, so he became the production manager, and they went on, and it was actually pretty hilarious. If it hadn't been true, it was actually kind of funny. But I want to again extend this idea of the wrong team a level deeper to manufacturing technology. I often hear, as I talk to people within my small part of the world, that they are specifically not going to hire some people or do things a certain way because that's the way it's always been done. And as somebody who's been around a long time within manufacturing technology, that notion makes me recoil to begin with. Actually, the path that we're on often is a reflection of the set of experiences, right? And so when people say, I'm not going to hire somebody who's really experienced because I don't want to do it the way it's always been done, sometimes you're rejecting the fact that, in fact, the environment you're going to try to operate in has reasons that it operates the way it does. I'm working with a startup in California, and after some discussion and negotiation between us, the founders, who were all technical guys, went out and hired a 55-year-old guy who has experience in supply chain management, and he ran a service organization, and he is their production manager. And from the day he started, he said, we are going to build your production process from the bottom up, so it's going to be ISO compliant, and when we get done, as hard as this is, you're going to have a robust process that's going to work. And they embrace that. And as a result of it, they are doing fantastically. They just went out and raised a bunch of money, and I'm really proud of them. But rather than reject the notion that experience in this marketplace is important, they embraced it where it was worthwhile to them. So, lack of product market alignment, hiring the wrong team, and the third reason usually cited for failure is that companies run out of cash. And of course, I read that one and I laughed to myself, and I thought, doctor, why did the patient die? Well, he stopped breathing, right? Okay. Why did the company go bankrupt? Because they were out of cash. Seems pretty self-evident. Again, though, I want to take this question a level deeper, because I think one of the most concerning things to me, and one of the things that I'm evangelizing constantly, and if I walk around today, stop me in the aisle, and I'll evangelize you some more about this, is this question of investment within advanced manufacturing technologies. What I'd like to do is try to profile for you my perspective on what would happen normally in a startup relative to cash. And the black line you see on this chart will be sort of available cash to the company, and then, of course, time extends left to right. So very often, when somebody says they want a startup, what do? They go out to friends and family, they beg, borrow, and steal some thousands of dollars, they do a raise, and they have a certain amount of cash available to them. And during that initial period of the startup, the cash has a burn rate and it depletes. You're buying the first components so you can make a prototype in your garage. You file your first patent, which is always expensive. Perhaps you invest in some research somewhere that you need to advance forwards. But somehow we raise some friends and family money, we begin to burn it off, we begin to establish some confidence and credibility that what we're doing makes sense. So it's time now to do a serious money raise. Let's go out for a seed round. Seed round is usually much larger than the friends and family round. It gives us a lot more cash position. But for the first time, we're diluting our ownership in our company, and we're bringing in outside investors whose interests in our company may not be perfectly aligned with ours. And that's a force we have to wrestle with. But seed money is important. It's usually a lot more than the friends and family raise. It gives us some cash strength. Very often that money is used to hire our first salespeople or create a distribution channel, maybe facilitize for the first time, maybe buy some equipment to perform on an operation that we're outsourcing all the time. Seed rounds are critically important. Again, we have a cash burn rate, and eventually, if things go well, we're going to get to a series round, which is much larger. It is a much greater dilution in shares. it introduces much more outside influence on the actual conduct of our company, but it gives us tremendous leverage from a cash position. Hopefully, sometime in this process, we begin generating cash on our own. We start making some products, we get them out to market, we get some revenue in, and even though we have a cash depletion rate, eventually, if we're successful, cash depletion rate levels off, and we become cash flow positive, and we have a very successful startup. This is a profile of what I see as many startups go through this if they end up successful. Time frame, there's no singular time frame, but it's not untypical to say sometime from the early stages to cash flow neutral, 18 to 24 months is the expectation of the investment community. I want to contrast this directly with what I can observe every day within manufacturing technology. Are manufacturing technology startups different? Well, let's take exactly the same chart, construct it exactly the same way, and from my perspective, what I have seen is, generally speaking, the seed round occurs later and it's bigger. Generally, within manufacturing technology, that first investment round is required to be bigger because of the nature of the kind of technologies we're creating. And it happens later. Generally, the series round is bigger and it happens later. And generally, cash flow starts much later. This is kind of the essence of why I got up here today, what I see in front of me right here on this chart. I want you to imagine for a second the pressure that this creates on both the founders and the investors. You know, we're blessed to be in the United States. We are. Institutionally, we've created a place where capital flows to its best use rapidly. Investors oftentimes can choose between advanced manufacturing technology, soybean futures, or a new app for your iPhone. They can invest in any one of the three. Why would they choose manufacturing technology? Well, those that do face the fundamental question that, in fact, the dilution is greater, it comes later, cash flow comes later, and the voice of the investor is generally larger because of greater dilution. And instead of seeing that same 18 to 24-month cycle that we see with many startups, very often this cycle is 36 to 60 months. So, from a macro perspective, and I tend to always see the world in its largest context first, then I kind of work my way down. What happens then in manufacturing technology if, in fact, what I told you is true? I think two things. The first is that because of the pressures we feel as a result of these funding streams, we tend to take technologies to market too soon. Those technologies get accepted in an experimental sense, but in fact, in many cases, they're not ready to be on the shop floor 24 hours a day, 7 days a week, 365 days a year, giving you 100% quality and all the things we talked about before. This is a serious, serious problem from my perspective. And the second is that because both investors and founders understand this dynamic, we have lower than normal capital flows coming into the manufacturing technology sector. And yet I remain amazingly optimistic about the future. When I see the power of combining and integrating technologies that deal with data creation and data capture, that deal with material science, that deal with taking things to market, that deal with machine technologies, that deal with sensor technologies, that deal with artificial intelligence and robotics, I remain amazingly optimistic about the potential of the manufacturing technology sector. I was just in Chicago at the International manufacturing technology show, and I was overwhelmed by what I saw. So I remain amazingly optimistic. And yet, we have a fundamental problem, because to get from where we are holistically and globally with the large thing we're dealing with and get it to where we want it to be, we need more investment dollars. And we have a dynamic here that makes those investment dollars difficult to come by. But I remain convinced that the difference between where we are and where we want to go is just investment. It simply is R&D dollars. If we throw enough of them at these basic science problems we have, we'll solve them. And so even at my 40 plus years and 65 years old, I sit here and go, we're on the cusp of something great. Has it developed the way many people anticipated? Well, no. And I think often that's because we created higher expectations than we had the capability of delivering. But I remain amazingly optimistic. Now, why am I saying all these things? Because I thought about this talk and I thought about how depressing the first part was, so I thought I'd better say that at the end. So what are the reasons for hope? If you're creating a startup in manufacturing technology, I, Dave Burns, offer you these 3 pieces of advice that I believe can make the difference. The first is, hear the voice of the customer. Sounds trite, of course, but bridge the gap between your individual experiential set and the experiential set of the industrial customer that you say you want to please. If you bridge that gap, if you really understand how they do what they do and when they do it, and you take the time to learn that before you try to put technology on the market, you'll be far more successful. Find people with experience in the markets that you say you want to serve. There is no shame in acknowledging the past and the experiential set that the past brings to us. There's no shame in that. The outright rejection of the past simply because we want to be different seems to me to be an almost silly idea. Why don't we blend the amazing power of the creativity of all these new technologies we have with the experiential base of the past? If we have that combination, we will win. And finally, the phrase I use with the companies that I advise continuously is perfect the tech. Stay in the basement. Don't bring it out until it's ready. You know the difference. I know you want a Ferrari and a Learjet. I know you do. Perfect the tech. Take your time with it. It's hard work, but the beauty of it is, if you do that hard work, it's a torturous path for somebody else to follow you. Take your time, be patient, engage people that understand the markets you want to serve and understand your customers. These ideas seem trite, but I will tell you that within the advisee set that I have, those that, in a sense, follow this path have been far more successful than those that haven't. So, once again, I'm excited to be here in Birmingham. I'm very grateful to TCT for the opportunity to speak to you. I hope this all makes some sense from the context of startups, and I hope you enjoy the rest of the show. Thank you.